In this video, I want to take a look at two kinds of symmetry. The first is line symmetry. The second kind of symmetry we'll talk about is called rotational symmetry. So when a figure has line symmetry, as you have probably been talking about for years and years, it means we can just take a figure and fold it onto itself or reflect it onto itself. And we call the line that we can fold it on, or the mirror line, the line of symmetry. So for example, let's take a look at a couple hexagons real quick. So I'm asked to figure out how many lines of symmetry the hexagons have. So this first hexagon, I can imagine folding it in half vertically. I can also fold it in half horizontally. So I would say that this has two lines of symmetry. Again, you've been doing this for years, so that should come as no surprise. The second hexagon, the regular hexagon, there's lots of symmetry when the figure is regular. I could fold the hexagon again, those same two directions, either in half vertically or in half horizontally. However, there are more lines of symmetry than just those two. I could also fold the hexagon that way to have symmetry, as well as that way, so I'm up to 4 lines of symmetry. However, there's even more. I can also fold through these last vertices, so I could fold through there, and I can fold through there. No matter where I fold it along those lines, the hexagon would be symmetrical. So this had a total of 6 lines of symmetry. For a hexagon that looks sort of like a spaceship, this time, the only way I can fold it in half to get it to line up with itself is horizontally right down the center, so 1 line of symmetry. This last part asks us to come up with a hexagon that has no lines of symmetry, so you may want to pause the video and think for a second of what you could draw. Otherwise, let's see, I'm pausing, letting you think, if you haven't paused the video yourself. I don't know, I came up with something that looked like, I don't know, a weird looking whale or something, so oops, let me make sure I have 6 sides there. 1, 2, 3, 4, 5, 6. Yeah. So a hexagon that has no lines of symmetry, maybe you drew something similar to that, but definitely not symmetrical, not very pretty looking. Notice that too, the more lines of symmetry we have, the more perfect, I guess we could say, the shape was. More lines of symmetry we like. Things that don't have symmetry look ugly to us. At least I think so. So that's line symmetry. Again, nothing real fancy there. You've been talking about that for years and years. One thing that may be new to you is something called rotational symmetry. Rotational symmetry means we can take a figure and rotate it so it looks like itself. In other words, we can turn it so it matches up with what it originally was. We have to make sure that for rotational symmetry to be there, we have to rotate 180 degrees or less, a half turn or less. Obviously, if we took a figure and rotated it 360 degrees, well, anything would have rotational symmetry if we rotated it all the way around. So we don't count that. We have to do 180 or less. So let's take a look at a few figures and see if they have rotational symmetry. The first example we have is this fan or pinwheel or whatever it is, and yeah, that's going to show rotational symmetry. If you take your notes, take your paper, and turn that 90 degrees, if you do a quarter turn, you can see that it looks like the original figure. Next up we have this diamond rhombusy type thing, and once again, yes, that would show rotational symmetry. If I took it and spun it 180 degrees, I would have that same shape. Now, some of you are really good at figuring out what this rotation is. You can imagine turning your paper, or you can visualize in your head. I'll show you once we finish these last 2 examples of a way you can sort of use a formula to come up with that answer if you're having difficulty. So next up is this right triangle, or at least I'm going to assume it's right, and there's no rotational symmetry in there. The only way to get it to line up with itself is to rotate it all the way back around, which we said doesn't count because anything would show rotational symmetry. So no, that doesn't have anything. And last up, this diamondy star type thing. Yeah, that shows rotational symmetry. If I turn my paper, I could get it to match up with itself. Well, let's say I don't know how to find the degrees I turn to do my rotational symmetry. Here's a little formula that you can use. 360 divided by S. And S is always going to stand for the number of lines of symmetry that we can draw on this. So back to like line symmetry. So for example, for this little star diamond type thing at the end, let me draw in all the lines of symmetry that I have. I can fold this in half there or there. There's 2 more ways though. I could also fold it in half that way and that way. So there's 4 total lines of symmetry. So to figure out the rotational symmetry of this, take 360, divide it by the number of lines of symmetry you have, and that will tell me that it's going to take 90 degrees or a quarter turn to get this to line up with itself.